It is great to see you all back with suntans. Welcome. I have ambitious plans for today. I'd like us to talk about these two papers to kind of get in the mood, remind ourselves what we were talking about before break. I assume everybody's memories has been wiped clean by spring break. This is the intended outcome of spring break, so that's okay. But hopefully we'll refresh our memory of our discussion of experimental design a little bit. So we have a couple of papers. I think nobody signed up for the NeurIPS experiment, as far as I could tell, unless there's a late arrival. There's not. It's okay, we'll do the other two. And then I want to go back to interaction effects and a few other things, and we'll see how far we get. I have some R to show you. Maybe we do some hands-on stuff. If you feel like it. Sound good? Okay. Do you want to go? Who is doing? Yeah, please.
Okay. So this paper is about reviewer biases in single versus double blind peer review. I thought it was quite interesting because two of the authors were just asked to be part of the program committee of a conference, and they were asked if they wanted to do it single blind or double blind. And so instead of just studying for one, they were like, okay, let's do an empirical study to see which one works best in terms of biases. And so basically they wanted to see if there were biases between these two versions of peer review. And so basically what they did, and it's in the next slide, they just did a controlled experiment where in this conference, which was an ACM conference, which is a big venue with just 50% of acceptance rate, they just divided all the papers between a group of single blind reviewers and double blind reviewers. So for the same paper, there would be two reviewers that were given a single blind version and two would be given the double blind version. With what this means is, if you go to the next slide, is that during bidding, reviewing, and giving scores and ranking, the single blind would just would get both the names of the authors and the institutions, as well as the papers. And for the double blind, they would not get any information that would identify the authors or their institutions. And basically, they were taken out of two different pools that were disjoint, and there were 500 papers for which they did this. Each of the reviewers had to first bid on the papers they wanted to review, then they had to review them and give a score and ranking. Reviewing means that they would write a small review, and then they would say if they had a strong accept, weak accept, or weak reject or reject as a score, and rank the papers that they read in order. And basically the authors wanted to do this and test three hypotheses that were based on previous theories that I thought was quite interesting. So one of them was the Matilda effect, where female authors receive lower scientific recognition when compared to their male counterparts. And this is actually quite an old theory that has been made in 1870. Then they wanted to check the Matthew effect, that basically can be represented as the rich get richer and the poor get poorer. In this context, it would mean that authors that were famous would get higher acceptance rates when in single blind review. And also they wanted to check if the institutional fame or quality would change anything in the acceptance rates. And so what they did in the next slide was to get all the information that they could from the papers and then create some other information related to it. So the original information in the papers were the author's names, institution, and country. And then they created these covariants that were related to if the paper was from the United States, if it was from the same country as a reviewer, female author, famous author, academic, versus top universities and top companies. And here you can see more or less the fraction of papers that have each of these categories. And after this, they created also a score of quality that was only for the blinded paper quality score. So for the double blind one, they created the average quality score of the double-blind reviews of that paper. So what they basically did was, after the reviewers finished everything, they gave a score, and they used that to calculate this metric that would represent the quality of the paper. And their first analysis was about paper acceptance, and the question was more or less to try to predict the odds that a single blind reviewer would give a positive accept score to a paper. And to analyze this, they used the logistic regression analysis that has something to do with what we also saw a couple of classes ago. And in this table, they show that the p-values with significance are those three highlighted in green. So for our top companies, famous authors, and top universities, it is more, these coefficients are relevant and significant to a single blind reviewer giving a positive accept score to a paper. This means that there is a correlation between these three factors and the accept score given to a paper. After this, they also did some analysis to the bidding part, and they asked two questions. The first one was if single blind and double blind reviewers bid for the same number of papers. They used another statistical test, and they saw that single blind would bid for fewer papers. And on average, there was a 22% decrease in bidding in single blind when compared to double blind. And after this, they asked, so if they bid for different numbers of papers, is there anything different between the papers that they do bid for? And in here, they use again a logistic regression and saw that two of the significant features were company and university. So the two, if the company and the university were famous or were tasked as having more quality, these papers would be more bid than by reviewers than the other ones. And basically what they saw at the end was that these NAT2 effects and the institutional fame or quality were both relevant, both to the acceptance or not of the papers, and for the bids, only the institutional fame was significant. After this, they asked a couple more questions about the Matilda effect in different areas and about some other questions, but they did not collect any significant, statistically significant results. And so they were not the main conclusions of the paper, but they started doing other tests that were more complete and with other theories to see if there were other things that they could check.
Mm-hmm.
So basically, what I found interesting, if you go to the next one, that they did this controlled experiment of the papers with single blind and double blind reviewers to test some hypotheses that have been around for quite some time. And then they did a statistical generalization that we have been discussing with methods to find evidence in favor of the relationship or effects of the different factors or coefficients that appeared in the papers. And that's more or less.
Cool. Thank you. This causal? Is there a causal relationship here? Conversation before break. 3 ingredients for a causal relationship. Long. Well,
First one is correlation, but that's not sufficient.
mhm.
Well, it has to also happen before and in time, there can't be any other similar explanations.
Great. So is this, do we have enough evidence to conclude a causal link here? Oh, yeah.
I mean, the explanation could also be that institutional claim is related to how many resources an institution has, which may result in like higher quality data.
Papers, I mean,
Yes,
the
which may result in a higher quality paper.
got it, right. Is there, how are the two groups compiled, Elizabeth?
One distinction, do they have single blind and double blind reviewers on the same paper, or is it? Okay, because wouldn't that imply that there is more of a causal relationship, because if it's that they're reviewing the same paper, double blind versus single blind, like, but the double blind is less biased for those qualities of the paper than more isolated.
Same paper, right? Different style reviewing.
Yeah, one of the things that they actually mentioned in the threats to validity part is that they all went through this process until the revision, but then they started discussing things in the reviews. And there might have been a way for the people that had single blind to talk about the authors or the institutions, and they could not prevent that from happening. So there are some threats to validity here. And also, different reviewers also have different views of the same paper. It is common to have, even from the same style of revision, have very different outcomes from different reviewers, depending on their expertise and what they think about the paper. So that could be also another threat to validity.
How do we read this? Tell me about, yeah, I guess tell me about these.
So if it is for me, I must say I know very little about the statistical methods. What I understood was the p-value. That makes sense about what we thought so far. And that was what they mentioned also in the text. So if anyone else wants to jump in on this.
Yeah.
I'm assuming the coefficient would be the strength and the direction of the relationship. So like how much the top company affects it is perhaps more than if it's a famous author. And it's like positive. So if it's a top company, it's more likely to be accepted. Whereas the negative ones would be the opposite. We don't have any significant negative ones.
Okay, great. Yeah, so let's talk about this a little longer. So these are some flags, I assume, right? Some booleans or something, binary variables, right? So is the paper from a famous company, yes or no? I assume. Is it from a famous first author, or how does it work?
They just found if there was one famous author in the group.
Any famous author?
And famous author was being at least 3 papers in that conference before.
Okay. And similarly, is it from a famous university, yes or no? What does that mean?
They went to the 500 top companies or 50, I'm not sure, and they just searched for them and used them.
From some ranking.
Yes.
Okay. Now, there's so this is a Boolean flag, okay? And the coefficient, estimated coefficient for that tells you how the response variable, in this case, the likelihood of the paper receiving an accept score, changes when you go from, I don't know, the false condition to the true condition of, each of these variables. Now, here's the $1 million part of this. Ready? While holding constant everything else, which is amazing. Okay, think about this for a second. We talked about the ingredients for a causal relationship before. Okay, does it come earlier? Well, yes, by design. Is there a correlation? Well, yes, it's statistically significant. We can talk more about how they arrived at this. And can you exclude plausible alternative explanations? Well, in general, not fully with an observational study. This is a to experiment, maybe this is much better. But in general, we do this kind of analysis on observational data, maybe, and there we can fully exclude all possible alternative explanations, except you can control and hold fixed at least a lot of the measurable plausible alternative explanations. That makes sense? This is a really powerful idea. Okay, so here they're not computing in isolation the correlation between, I don't know, papers from famous companies and acceptance decisions. But they're doing that, they're estimating that correlation while holding constant everything else that they have in this table. Like, you know, is the woman author, is the reviewer from the same country, et cetera, et cetera. Like holding constant these other variables. This is how the response varies on average with changes in each of these independent variables. Really powerful idea.
Like at what value do you hold the other constant?
Right, so it doesn't matter for interpreting this.
Mhm.
So basically any value.
Okay.
But if you want to instantiate, this doesn't matter, it's independent of the other variables. If you want to instantiate this, you're going to say, you know, what's sort of the magnitude of the expected difference for, say, the average paper. Right, so then you could, you know, you figure out what the average or median paper is in your sample. Let's say maybe the average paper, you know, is from different countries. Maybe that's the default. You instantiate and so on and so forth. And you plug in all those values in the equation, and you get, you know, some value for the response. You could do that. But the beauty of this is, you know, all of these, each of these on their own, you can interpret independently of all the other ones. Right, so this is not causal. Maybe with an experiment design is, with an observational study is maybe not causal, but it's still really powerful because it allows you to isolate the effects of at least the obvious measurable covariates, which means, you know, you can exclude plausible alternative explanations. Footnote, as long as they're measurable and you have good ways of measuring them, right? So that's hard. But in principle, you know, this is a great idea. Right, it allows you to get much more precise estimates for the thing you care about. Okay, so we'll see this idea recurring over and over again. Right, experiments with random assignment are the gold standard. It's great when we can do that. Often we can't do that for lots of reasons, and the best we can do is observational studies. And then the game there is how close can I get? How confident can I get to making a causal claim, but never as confident as the true experiment for sure. But you try to get as far as close as you can. Okay. So okay, so here you would say, since this is logistic regression, you probably have to take the exponent of these coefficients. So that would look something like, I don't know, is it a calculator? I do have a calculator. Okay, so here is what was 1.49 or something? Oops. Famous author 0.49. Okay, so papers from famous authors are 1.6 times more likely to get an SF score compared to papers without famous authors holding constant whatever else we had in that table. That's how you read this. Okay, and then you go back and say, oops, famous universities about the same, famous companies 0.74, right, 2.1 times, more than 2 times more likely for papers from famous companies to get an SF score compared to papers that are not from famous companies, holding constant all the other things. Okay. Yeah.
This holding constant thing really reminds me of what we talked about the week before spring break. Forget what it was, but it was like the match. It was like the last thing you needed.
Right.
On its own is not sufficient, but given everything else is sufficient. So I'm just wondering, how is this not causal? Because it almost seems like.
Yeah, so it's not causal because you did not directly manipulate the thing. So you could have spurious correlations for reasons you cannot observe. And there could be confounding variables, alternative explanations for the observed difference in outcomes that are due to something that you just don't observe, right? So here, you had the ability to observe a few confounding factors, and you have variables in your model to account for them, but maybe there's others that you couldn't measure.
I see.
Okay, and if you don't do here, I'm not. This is probably very close to causal if they have the random assignment in there, right? With maybe the caveats about leaking information and so on during the discussion phase. But assuming this was an observational study, not with random assignment and the experiment in the true sense, then there could be potentially other things that you just did not measure because maybe you didn't think of measuring, or maybe you didn't have the ability to measure, right?
I see.
And you just can never be as confident, right? You can never be sure. Whereas if it's a true experiment with random assignment, you can be very sure because on average between the groups, all of those other things will have been the same.
Is this considered a natural experiment?
This here is probably considered a true experiment if there's random assignment and
Without randoms?
It could be a quasi-experiment or a natural experiment. Could be a natural experiment. I think natural experiment, the term is used more for naturally occurring phenomena. This was, maybe not naturally occurring, was sort of artificial. So maybe a quasi-experiment would be a technical term. I don't think it matters too much what you call it, unless somebody's very pedantic about it.
Just, all right.
The terminology, yeah.
What else would need to be more randomized? Because didn't they do random assignments before those? So I'm confused about what inherently would be different between like this variation where it's not necessarily causal versus the variation that would be causal.
I think this probably is causal. I was sort of describing a hypothetical where maybe these the data that was used to estimate this model did not come from this experiment where the conference organizers randomly assigned papers to the different conditions of review, but maybe they came from mining, our logs of whatever conference management systems or something.
Yeah.
And kind of reconstructing, this hypothetical experiment that you didn't actually run yourself. Right, so in that scenario where you didn't actually run the experiment yourself, you can be quite sure. Here, maybe they can be very confident.
And also, what does the constant BPQS mean?
Yeah, I don't know what the BPQS thing is.
That's the score of quality from the double blind. So at the end of the revision, both gave scores, and the BPQS is called the blinded paper quality score. This is the average quality score of the double blind reviews of that paper. How is that calculated? It's just an average of what the reviewers gave to the paper.
So I guess the assumption would be, good papers are more likely to get accepted than bad papers.
Okay.
Right, so this is a way to control for the quality of the paper. And, still estimate those effects you really care about. I had one here, I'll come back to you in a second.
It's a same point, so.
Same point, okay, please.
Just to rephrase your objection to, looking at historical data, the reason you can't, the reason you need to actually run the experiment yourself instead of just looking at historical data is because someone could have deviously run the historical data to have some secret confounding variable that you don't know about that you'll have to find.
Because presumably the historical data was not recorded as the result of some true experiment with random assignment, but rather, recorded
Some
somehow.
random thing could have happened that you'll
That's right.
unlikely that you'll ever find. Yeah.
That's right, yes. So you can't quite be sure. You try to So this is again where theory comes in, by the way. We keep talking about this idea of theory. So often, and I think I went on this rant before, let's say you get a reviewer saying, well, but like you didn't control for X in your analysis, and that's maybe a plausible alternative explanation or something. And so to me, that's not enough. You also have to articulate the mechanism through which it is a plausible alternative explanation. You can't just say you didn't control for the conference location. Like, oh, the conferences, you maybe analyze different, I don't know, years of a conference and you didn't control for the location, and the ones in Europe are always more likely to get accepted than the ones in North America or whatever, right? Explain the mechanism through which that's plausible. You can't just say you didn't control for location, therefore I reject your paper. You have to also argue as a reviewer, and similarly as an author, you have to argue that there is a mechanism through which that relationship could exist. And this is where maybe theory comes in, or just your analytical thinking or something. Like you have to convince the readers that this makes sense. And as a reviewer, you have to convince the authors that this is a valid criticism. Like I often, I don't know. Yeah. Somebody asks, are there confounding factors? Sure, yeah, tell me one. I'll tell you if I considered it or not, if you tell me one, but I can't just make them up. Okay, and rant. More on this? Okay, great. So this idea of estimating some regression, we will see basically for the remainder of this semester in some form or another. And it's basically what everybody does in all the sciences to, compute associations between variables. And it's very useful. So we're going to hopefully practice enough with a couple of the very basic ones that you will become fluent at those, and then you can pick up other ones as you go along, depending on your needs as they come up in your own research. Okay, good time maybe to move on to the second one.
Did you get the link that I sent you?
I did.
Awesome. Do you mind if I come up?
No, not at all. I will be happy to sit down and listen to you.
I have a lot of transitions.
I look forward to sitting in this thing.
All right, so I am presenting on two papers. The first one is Formal Methods Application and Empirical Tale of Software Development. And the second one is a critique on the first one. Also, I'm going to apologize. My voice sounds a little hoarse. I don't know if it does to you guys, but I lost my voice over the weekend, so bear with me if it sounds a little hoarse. Wedding. All right, so we all know that formal methods is awesome, right? So there's really not a reason to question whether it's awesome or not, but this paper did exactly that. So the goal of the paper is to show empirically that formal methods yields better programs. And by better, I mean, they mean better than not using formal methods. So I'm actually going to refer to this paper as the Sobel paper. That's the first author over there. And the way that the Sobel paper shows that formal methods yields better program is by using an experiment. So first I'm going to overview the experiment just to give you guys an idea about what it looks like. The experiment involves two groups. The first is a formal methods group. The second is a control group that doesn't use formal methods. And basically these two groups of people have a task. They have to develop an elevator system. They have to program an elevator system, and this is a class project. So it's actually two different classes. In the formal methods group, so this is a formal methods class, they use formal methods to develop this elevator system. In the control group, they don't use formal methods. They're not trained in formal methods, so they don't use it. The main result of the paper is based on the correctness of the programs. The Sobel paper found that the formal methods groups, in the formal methods group, 100% of the team's programs are correct. They found that the control group, 45.5% of the programs are correct. All right.
Do we pause for inviting effect?
Formal methods, everybody. All right, so you're already a little suspicious, it seems. So you guys are correct.
Can we hear, if you haven't read the paper and you don't know the punchline, can we hear about some thing you're worried about with this design?
It seems like we're assuming true, like, but the way that better has been set up to be is whether or not it's formally correct, which is what formal methods ensures.
Oh, I didn't say formally correct.
Oh,
Correctness. No, it's a really good point. If I thought about that, I would have said this on the slide. That's my apologies. Correctness, according to test cases. I'll talk about that later.
okay. There are other reasons though, you know, like readability and things like that, that you might want to embed in your definition of correctness.
You have to be very clear with defining what you mean by program purpose for people who did that. Yeah.
It's a great point. Yeah.
One quick question. So how many times are they allowed to test the programs? Are the students or are the participants allowed to test their programs, or do they like just write the program and submit it?
The paper wasn't clear on that. They could basically test it themselves, but as far as I know, they did not have the golden set of test cases, which the instructors were judging them
I
by.
guess so. Okay, that answers my question, because if both groups are only allowed to test it once, or like only allowed to write the program and to submit it without testing, without being able to run the program, then it wouldn't be a fair comparison, I guess.
Yeah, it's a good point. That's a very good point. If it was like grade scope, so.
But presumably the way of checking was the same between the groups, so
Yeah,
why would it matter?
that's true. Never mind.
Well, it's not that it'd be unfair, but you might be able to not draw as much of a conclusion if you could just keep testing. But anyway.
Did they talk about the amount of time?
Yep.
Taken between?
No, you guys are poking the right holes. They didn't talk about that at all. In fact, I'll come back to that later.
As a student is there any difference between these two groups other than they know the form method or not?
There's no difference, actually. The only difference, this is the claim, is that they're identical except for one group of students has learned formal methods and the other one hasn't. Good segue.
Could the formal method students have been like more familiar with the elevator project? I feel like that would be one of the things that someone might work on in formal methods class.
It's a good idea. I got the impression from reading the paper that it wasn't like a common problem that we should be concerned that maybe some people knew about before. And it was a complicated enough project where even if you kind of knew it, you know, you had to do enough work where.
Also, do they write the program, or do they automatically let some sort of synthesizer to generate the program?
They had to write the program. They just use formal methods for design.
Okay.
Yes.
I still haven't heard something that was sort of key to our discussion last week and earlier today. Something that you're maybe all taking for granted here.
Is it random?
It's something not happened before something.
Well, I think I probably know what you're talking about. Well, actually, I'm not sure.
Go for it.
So okay, I guess maybe I didn't say it, but basically one of the groups, the formal methods groups, they opted into this curriculum. So there's like a self-selection bias. I'm not sure if that's what you were going for, but I'm not surprised people didn't mention that because I actually didn't say that yet. So maybe should I continue?
Yeah, please.
Okay, so yeah, there's a little bit about the participants, I'll say. So the participants were all college students. Most of them were juniors. They're all computer science majors. And they took identical classes except for two classes. Basically, what I should really say is there was two curriculums. There's the main computer science curriculum, and there's the formal methods computer science curriculum. and students
Oh, yes. Sorry, we didn't see this. I was sitting down and didn't see the chat at all. Can you hear us? Okay, perfect. Thank you. Thanks.
And finally, there are 6 formal methods teams and 11 control teams. Okay. Okay, so now to the task instructions. I would think that they'd have the exact same instructions, right? Well, it was a little bit different. So the control group was tasked to hand in their source code and the program of the elevator program they're supposed to create. Optionally, they could also submit a UML diagram with their design, and no team submitted. The formal methods group also had to hand in source code and executable, but they also had an additional requirement that they had to hand in a formal specification. They also had the option to submit a UML diagram, and half the teams submitted a UML diagram in this case. Oops. Okay, yep. All right, so onto the results, which again are based on program correctness. All right, so a program is correct if it passes 6 test cases. Good definition for correct, right? And it's a binary thing. It's correct or it's not. All right, 6 out of 6 formal methods groups programs are correct. 5 out of the 11 control programs are correct. The conclusions that the authors of the Sobel paper draw are that formal methods caused the FM's groups programs to be more correct. They claim that this provides causal evidence that formal method yields better programs. Can't say that with a straight face. All right, are there problems with this? We've already poked a lot of holes. Yeah.
Haven't established any, this is considered any other theories why, but the form methods group improved, but it could be not because they use something else. Methods could be something else.
Yeah, any ideas what it could be?
Okay, so say the people who know formal methods might be have more knowledge about software engineering in general, for example.
Yeah. Totally. Any other ideas?
So like thinking more about your code tends to make your code better. So like if you're thinking more about the design and intentionally designing your code in a way that will make it better, like just by based off of the hand-ins, like it's obvious that the second will have thought more about their code.
Yeah, it might have been possible that the control group just wanted to do the assignment and get it over with. Maybe they didn't actually do any planning at all. I agree with both.
I think the main problem was, as Long talked about, it's just not controlling for the abilities, CS abilities of each group.
Yeah, I totally agree.
Because they are using ACT, which is not a measure of CS abilities, programming abilities.
Totally. All right, you guys are all correct. We're gonna. All right, so basically this paper comments on the issues with the Sobel paper, and everything you guys said is gonna appear. So I'll call this the Berry and Tichy paper. I am not sure if I'm pronouncing Tichy correct, but hopefully I am. All right, so they identify many problems. So we can go through them one by one. And there's so many problems I didn't even have enough time to cover every single one. So here's an overview. So one is that the groups, big reveal, are not identical. I know, crazy. All right, so there may be a difference in the motivation. So we talked about how the formal methods group is self-selected. They opted to take the formal methods track. So they may actually be more motivated, right? They want to above and beyond to take these extra classes. So also, a potential difference in exposure to relevant material. So this is kind of what you were saying, Long, right? The formal methods group took 2 extra classes, one of which were a more advanced version of the data structures class that the control group took. So they may have actually learned more material. They may have just been better equipped to do the elevator project. There's also potential differences in learning styles. So another thing that the Sobel paper mentioned was that there was a survey given to the formal methods group and it identified them as collaborative and competitive. Unfortunately, the survey was not given to the control group, so we don't know anything about them. It's entirely possible that they're not very collaborative, competitive, and maybe that was a reason why their programs weren't as good. Finally, differences in skills too. So the formal methods group, again, they're self-selected, they were up for the challenge. It's totally possible that they were just better programmers. And in fact, in another paper, which I got the impression was kind of a journal version of the Sobel paper, they included computer science GRE scores for the formal for both groups, and they were higher for the formal method group. So it's entirely possible. In fact, seems likely that there is a difference in skill. So this kind of leaves room for alternate explanations, right? For why the formal methods group had better programs, more correct programs. The Sobel paper also did not consider the Hawthorne and novelty effects. The Hawthorne effect is when subjects act differently when they're aware they're in an experiment. And a novelty effect is when subjects act differently when asked to do something new or different. The Sobel paper, the Berry and Tisch paper comment that it's very likely that the subjects in the experiment were aware of the fact that they're in the experiment. So the Sobel paper, in other words, is subject to threats from the Hawthorne effect. I wasn't entirely sure why they might be at threat for the novelty effect. They didn't really go into detail about this in Berry and Tisch, but they did mention that this was a possibility. Yeah.
I think it has to do with the motivation. You're doing something new and exciting, you're more motivated to, if you're committed, motivated, you're doing a better job because there's the excitement of doing something new, greater.
Oh, okay. That would make a lot of sense. They had some quotes in the Berry and Tisch paper about how the formal methods group formed like a tight-knit bond, and they're already planning a reunion and everything like that. So they were quite motivated in that sense. Okay, that makes a lot of sense. Okay, so there's a lot of room for other theories to explain the results. So one of them is the difference in deliverables that we talked about before, right? So we had the formal methods group, in addition to delivering everything that the control group had to, they also had to submit a formal design. So this is kind of touching on what Elizabeth mentioned, right? Because if you have to include a formal design too, you're actually doing design. Whereas the control group didn't have to submit their design. So they may have just skipped design entirely. We have no way to rule out this possibility. So, right, the lack of design information means that it's entirely possible that it was the design, not necessarily formal design, that led the formal methods group to do a better job. So we don't know if the control group performed any analysis or design. Okay, this point is redundant. All right, another problem. The measurements are poor. 6 tests is not precise enough. It's a big program. 6 tests is clearly not exhaustive. In fact, the Sobel paper includes no information about which tests were even performed. I'll add some personal thoughts. I think that a binary test is not really granular enough. I personally think that if you get 5 out of 6, that's important information. So that's another critique of their design. And finally, they did not, in the Sobel paper, did not include threats to validity. There's 3 particular threats to validity that they should have considered at minimum. One is construct validity. Maybe you all know the definitions here, but I didn't, so I'm including them anyway. So construct validity is how well do the measurements reflect what we actually wanted to be measured. So, for example, on the previous slide, we saw that there was only 6 tests. That's not really a good measure of correctness, right? Maybe you know, it was testing, the testing wasn't rigorous enough, and it turns out that the control group was actually doing a better job. Their programs were more correct. It's possible. Also, the civil paper should have included internal threats to validity. And internal validity is whether the experiment is sound or trustworthy. Clearly, it's not. A good example of this is the fact that the control group and the formal methods group were certainly not identical, even though they're claimed to be. And therefore, it wasn't a true experiment as they claimed. It was a quasi-experiment. Also, they should have included threats to external validity. Do the results generalize? In other words, this experiment was performed in a classroom setting, and it's not really clear whether this might generalize to other settings like the industry, for example. So, despite all of these problems, the authors, so Barry and Tichy, still say that the Sobel paper is a good first step. Why? Well, because there's, at least at the time of this writing, I don't know how old this paper is, there's a lot of hype about formal methods. And, you know, you can believe in it all you want to, like me, but it's still important that you collect empirical data to support your premonitions. So this, Barry and Tichy write their paper as a warning. It's very important to get your empirical analysis correct, but the Sobel paper is still a good first step. It's important to perform the analysis. All right, that's it.
Yeah, thanks, Ian. Very good. Be checking here. I'm guessing there was no shared screen again. So quite likely Wei-Shin didn't see any of our slides. That's true. Sorry about that. Oops. Working until disconnect, and then we lost it. Sorry about this. I didn't notice until now. Okay, sounds good. So small rant. It's really hard to do this kind of work in the first place. So if you read something that was done less than perfectly by others before you, be kind when you criticize it. I haven't read this recently. I read this a while ago. The critique paper, it seemed to me a little aggressive at times with sort of the language they were using. We'll see a few more examples of this later on in the semester. I would like to put myself in the original author's shoes, and like how would I feel if I received like really aggressive criticism. I think if you do this, just be kind. Imagine the poor PhD students on the other end kind of receiving this. Same for when you're asking questions at, I don't know, a conference or something after a talk or whatever. Remember to be kind. And also, remember, it's really hard to do this kind of work, as we have seen here. To me, I think by the way, just another small rant. Hawthorne effect, the jury's out, not clear if it's a real thing or not. Learning styles, jury's out, not clear if it's a real thing or not. So a lot of these are still very much debated. So it's not clear that they're valid points of criticisms to begin with. But at the very least, this one with a difference in I don't know, computing skills or something, programming abilities, and the increased exposure to formal methods training and the extra coursework and all that, those are clearly the big confounding factors here. Okay, any closing thoughts on these experiments? Are we motivated to do experiments? Are we confident we can do them well? I see some skepticism. Okay, we're a little more motivated, hopefully, than we were, I don't know, a week ago. Okay, I want to move on to another thing. I started I started showing you this example last time and I got confused towards the end, so I'm gonna come back to it. I think I've made a little more progress on it. But first I want to talk about interaction effects in general. So, right, so how can we use experiments to tease out the effects of multiple variables at the same time and possible interactions between them? So let's see what that means. I gave you this example, I think, before. Let's say the speed with which you're typing on a keyboard is a function of two things. So how experienced of a typist you are in general. Like obviously people that are more used to typing are probably faster than people that are less used to typing. And the second thing is maybe the device itself, the kind of keyboard you're using certainly should have an impact on the speed with which you're able to type. Okay. So let's say we have an experiment here and we're comparing the typing speed between novices and experts on the one hand, while they're using two different kinds of devices, mice, I don't know, like navigating with the mouse to the point where you need to edit or something and then typing versus using a touch screen or something like that to do the same. Okay. So let's say this is the data you've collected after an experiment. Maybe you have run a design kind of like this. You're sort of switching people in different conditions. You're having them, use the mouse and then the touch screen in some order. Maybe you're counterbalancing. The other ones use the touch screen first and then the mouse and so on. You've done all of this. You've collected all of this data, and you get something like this. How do we read this? What are we seeing here? Interpret this for me, please.
That much faster typing speed for both experience and this.
One more time, please. I sort of missed the beginning.
That mouse is faster typing speed for experience and mobile user.
Yes, but let's build this up. Jeffrey.
If they have the same experience, the mouse will be better than touch screen.
Okay, yeah. So that's one way to read this vertically, right? The mouse is always better than the touch screen. Okay, and it doesn't matter if it's novices or experts. The mouse is always faster than the touch screen. Okay, it's faster for experts. It's faster for novices. That's one thing here. Okay, what's another thing we're seeing?
The improvement in typing speed, improvement rate does not depend on the improvement rate does not depend on the mouse or the touch screen.
Great. Okay. So another way to say this is everybody gets better, faster at typing with more experience. Okay? Regardless of the corollary. Don't you just love the internet? You're able, one more time, please, Elizabeth, sorry.
So you can learn to type faster on the touch screen than what you would have began on as a novice on the mouse. So like a novice on a mouse is not as fast as an experienced touch screen user.
What is that a fair comparison? Seeing these?
Yeah.
That's a valid thing to say, isn't it?
Would that be a question of concern? Yeah, I guess.
I mean, it would be especially damning to a touch screen to be able to say that you'll never be able to do as good on a mouse as on a touch screen. Or.
I see, so you're saying it's a good thing that this whole thing is not lower? Maybe.
Yeah, I don't know what the conclusions of the paper would be, but it wouldn't be able to argue that the mouse is always faster than the touch screen.
The mouse is,
If you're not controlling third theories, then that's a good thing.
right, all right, very good, I agree with all of this, great, thank you. Yes. Okay, so to summarize, is there an effect of experience going from novice to experts? Yes. Is there an effect of device going from touchscreen to mouse? Yes. Okay, very good. Here's another one. Is there an effect of experience going from novice to experts? Yes. Is there an effect of device? No. Okay, very good. What about here? Is there an effect of experience? Doesn't matter. Experts and novices, no difference. Is there an effect of device?
Yes.
Yes. Very good. Okay. So yeah, we talked about this. Novice users can select targets faster with a touchscreen than with a mouse. Experienced users can select targets faster with a mouse than a touchscreen. And the target selection speed for both the mouse and the touchscreen increases as the user gains more experience with the device. Everybody gets faster, but that's the interesting bit. Okay, there's this crossover thing that you're observing. The increase in speed is larger for the mouse than it is for the touchscreen. The mouse people get more better than the touchscreen people with more experience. Okay, so this is an example of an interaction effect between experience and device. And you see that manifested in this difference in slopes here, essentially. Okay. Long.
I remember a comment from, oh, this is really fast, comment from LMK, talking about how touchscreen should have styluses because humans can be more performant with styluses, but Steve Jobs thought that people would lose them fast, people would lose them, and so
yeah,
it never became a thing, popular thing, even though in theory experts would be better at that.
Except Apple Pencil.
Oh.
But if they lose them, then they can buy them.
For like $300, $300 for a pencil. Yep.
It's like 100 something. Yeah.
I lost. I have an older version. I don't know how much they are these days, but I think they're pretty pricey.
The first version is like 90 something. And the new one is
All right. So thank you for that comment. And one thing I want to bring up, we talked about when we talked about causal relationships between variables, we talked about two kinds of things that may come up. One was mediators, the other one was moderators. Okay. Which kind of thing am I describing in this scenario? Of those things that had to do with mediators or moderators?
Who remind us what those are?
Well, that's the question, isn't it?
This is either mediator or moderator, right? I mean, you could cast experience as a interesting.
Let's do a vote. Who thinks it's a mediator?
which thing, the experience or the device?
Experience.
So moderator?
The device. The increasing speed is larger for the mouse than for the touch screen.
I don't think you can make an argument for both.
I guess experience. Let's say experience. What is experience? Who thinks experience is a mediator? Who thinks experience is a moderator? Who does not have an opinion? Very good. Okay, so the mediator is the one that mediates, wait, the moderator? Mediator.
Mediator
That's
is
the
the one that,
important thing about this
Mediator
distinction.
in the middle, right?
yeah, the mediator is the box in the middle, and the moderator is the box on the.
Very good. Yes, so this experience moderates the strength of the relationship between device and typing speed. It moderates it, it changes its strength. The mediator is the thing in the middle, like it goes through a different causal chain. So if experience were a mediator, we would have to say that the device causes experience, and then experience in turn causes typing speed. Make sense?
So as part of your experiment, you have to, like, if it's a mediator, the words are too similar for me. Then you'd have to like show that it goes through this pipeline of like causal effects, and then the moderator is when it's like influential, but it was a pre-existing condition, like perhaps these people are more experienced as a result of time passing.
The moderator changes the slope here.
Okay.
The mediator, I can't really argue for theoretically. I can't argue for how how the device causes experience. I don't see a causal relationship there necessarily, so it's hard to argue for moderator. Which one? Mediator. Very confusing. Not the one in the middle, the one that's
Gonna do research without knowing.
very confusing. The point though is that you can use experiments with this crossover design to also estimate these moderator variables in addition to the main ones you care about testing.
So would you say that something that can cause some result but doesn't mediate something is a moderator? So like, if you had, because it's true that like experience in typing in general would cause you to have an increase in typing speed, but the device you use doesn't feed in to your experience.
Right. So there's no link here.
Right. Okay. So since experience where Z feeds into Y and also X feeds into Y, you would look at Z as a moderator on X when you're looking at just X's cause on.
Fair enough.
Okay.
I'm really confused by the way.
Can this be phrased in terms of like dependent variables?
Yeah.
It seems like we care more about moderators than mediators because you might not want to design an experiment that goes through multiple different causal things, or like what is a case in which you would want to construct a mediator? Sorry, that was two questions that I squished together. Just answer the first one about can this be expressed in terms of like dependent variables somehow.
The dependent variable is Y in this experiment. Because it depends on other things. The independent variables are X and to some extent V. Right? This doesn't exist in the description because we moved it here. It's the same thing. We're talking about experience. Okay. So if you were to estimate a regression, the dependent is the thing that goes on the left, right? So it's, Y as a function of X plus V, maybe. Okay. But here, there's no mediator effect, right? Because the strength of the relationship between X and Y does not depend on V, right? The strength of the relationship between X and Y So this would be, A X plus B V plus C, let's say. And the strength of the relationship between X and Y does not depend on V, only depends on A, no mediator. Okay, whereas if I express this as, AX plus B V plus C times X times V plus D, maybe. Okay. This gives me A plus CV times X plus all the other ones. So now the strength of the relationship between X and Y depends on the value of V, which is the mediator, which in this case is experience. That makes sense?
Is it relevant to say that mediators are like causally connected and moderators are like not? Like, what is the like? Is this related at all about the causality?
Right. So you're trying to establish or to estimate this causal relationship between X and Y,
Yes.
and
The mediator is something that directly changes the causal, the nature of the causal relationship, and the moderator is just something that like shifts it a little bit.
right, a moderator is something that would be an alternative explanation.
Yeah, okay.
Right.
I thought moderator affects the strength of that relationship, right?
Then we're doing this wrong. It's the other way around. The terms are very confusing.
Okay.
Experience is
Which do we have slides from before? What do they say? Which one is which? Can somebody open slides from? Should be moderator
That's what Google says.
affects the strength. Yeah. Okay. So this moderator.
and experience is the moderator.
All right. We agree on the terms. Very confusing. The other one is the mediator.
Choose emoji for the terms.
Seriously.
When do we talk about moderator and mediator together though? Like, I feel like those are completely separate and completely like independent.
Yeah. So we talk about them because, for example, this crossover design allows us to estimate these moderators or include them in the experiment design. The mediators, the other one that's missing here, is a plausible alternative explanation we should try to exclude in order to establish this causal relationship between X and Y. So we need to be aware of them too. To establish this, we need to be aware that there's no Z there. Yep. That's why we talk about it together. On.
So the experience of the moderator and which device would be a mediator?
No, I think that we have no mediator here
Okay.
in this scenario. We decided that the thing we're talking about is called a moderator. And that's the only thing we're talking about. That makes sense?
Device and experience are both moderators.
You could do it that way, right?
Okay.
You could, if you care more about V than you care about X.
But one of them is going to become the independent variable. One of them is going to become an alternative explanation.
I mean, I can rewrite this in terms of the other one.
Sure. Yeah. Of course. Yeah. Yeah.
So it sort of depends which one you care more about, which is the core research
Like a
question.
Semantic distinction to the question you're asking.
Yes.
Maybe you can think of the moderator as a Discord mod that wants to kick everyone out. Kick all the alternative explanations out.
Sounds like a good cue to kick you all out of this class. See you on Thursday. I won't have time to show you. I wanted to show you some R stuff, but I won't have time. I will do that on Thursday. So I won't start doing it now. I wanted to show you how we estimate these interaction effects directly in R and how we interpret them. Okay, thanks. Oh, okay, one more thing. Before I go, one more thing. This is gonna be fun. Can you have an interaction without having any of the first order terms?
First order terms.
Right, so, there's no effective experience. And there's no effective device on average,
Yeah,
But-
it's possible.
there is an effect of the interaction,
Yeah, it's possible.
which is mind blowing. Okay, crazy. That this can happen. So on average, the two devices are equally fast. And the two sets of users, experienced and novices, are equally fast. But there is an interaction between device and experience. Which is very counterintuitive that this can happen.
So what do you do when this happens? Like, how do you analyze it?
Really hard.
It will show up in your regression, and I will show you that next time.
One of the things I don't like about this graph, I know it's just for